Copy 724, right. Center maintain 2000.
Center maintain 2074.
Comment 504 to center maintain 3000.
3000, comment 504.
This is going to be the second video about navigation. We'll try to finish everything about navigation in 3 videos. So yesterday, like in the last video, we were talking about the VOR and VORTAC. Right, what are they? So the VORs, they are the very high frequency radio stations that project radials in all directions, like in 360 degrees. You can think of them as like spokes from the hub of a wheel. So each of these radials is denoted by its outgoing magnetic direction. And remember that almost all of the VOR stations will have the VORTAC. What is VORTAC? They are like the VOR tactical air navigation. Basically, they provide standard bearing information of a VOR plus distance information to the pilots. Again, VORs operating frequencies. So they operate between 108 to 117.95 megahertz. That's the operating frequency. Like they are above the FM, because FM just finishes before 108. So they are above the FM and goes up to 118.95 from where the radio communication starts. Okay. What is a VOR radial? Again, the radial is defined as a line of magnetic bearing extending from an omnimeter range VOR, just like we talked about it, like what the VORs are. So radial is the line which is of the magnetic bearing extending from the omnidirectional range. And another thing about the VORs is like their classifications. So they are classified as terminal, and low, and high. These are the classifications of different VORs. Basically, they are different in terms of the distances. So I'm going to be talking about like the reception distances. So if the classification is T as in terminal, then L, then H has multiple ones. Why they have multiple ones is because one H high is depending that you are flying below 18,000 feet. Then you are flying between 14,500 to 17,900, a little bit above than the 18,000. Then you have the 18,000 to flight level 450, then above 450. So that's why we talk about them as separately. But here are the distances. You do not have to memorize them, just need to know that the terminal VORs, they can cover up to 25 miles. The low categorized VORs has the reception up to 40 for the high and 100 for that, and then we have 130, and then we have 100 nautical miles. That's the reception of these VORs. Okay, limitations. So what limitations apply to this VOR reception? So remember, the only limitation is that they are subject to line of sight, and the range varies proportional to the altitude of the receiving equipment. So they need to be in the line of sight, and reception, as I have shown in the table, that the reception changes by the altitude. Then methods for checking the VOR accuracy. So if you want to check the VOR accuracy, these are the couple of different ways. There is a VORT check, then we have ground check, then we've got the airborne check, then we have dual VOR check, then we have selected radial over a known ground point. So selected radial over a known ground point, and mostly they are plus or minus 4 degrees. Like with these checks, you can actually be accurate up to plus or minus 4 degrees. DME. So what is it? It's the distance measuring equipment. You could be on the ground and use the DME, or you could be airborne and you can use it. So used to measure the like the slant range distance of an aircraft from the DME navigational aid, and it measures the distance in nautical miles. Okay. And the GPS, just wanted to cover it. It's not different from the GPS we use in the cars. Actually, I'm sorry, I'm gonna take that back. So this is a global positioning system. It is very similar to what we use, but over there, like, we have a cell reception, and so we have a GPS sensors and stuff like that. So the GPS is the global positioning system, and it is a satellite based radio navigation system that broadcasts a signal used by receivers to determine a precise location anywhere in the world, right? And three functional elements of the GPS. Okay, one is called the space element, then we have the control element, and then third one is the user element. So space element, it consists of 30 satellites, right? There are 30 satellites, and the control element consists of a network of ground-based GPS monitoring and control stations that ensure the accuracy of the satellite positions and their clocks. Okay, and user element consists of the antennas and receivers, receiver processor, onboard aircraft that provide positioning, velocity, and precise timing of the user. So why did I say that I take it back? It's just because of the control elements. So this GPS system is made of the satellites, which is the space element. There are a total of 30 satellites, and then we have the user element, which does have a receiver and it is talking to it. But then the control element is like the one which is the network of the ground-based GPS monitoring and control stations, and basically they ensure that the accuracy of the satellite positions and their clocks. So they talk to the satellite if they are out of sync, and basically keep an eye on the timing and the positions of the satellites. Those were the things I wanted to cover. Thanks for watching.